All right, so we're Formlabs. We make the Form 1 Plus 3D printer. When we launched the Form 1, this was actually the first high-resolution desktop 3D printer. And I say high resolution because we use stereolithography as our printing method. So this is an SLA 3D printer. And it might be a little different from some of the other desktop 3D printers which are widely available. And with stereolithography, that mainly means we're working with photopolymer resins. So all these parts printed from their initial state, which is a photopolymer liquid, and we use a UV laser to cure it. So this is actually the oldest 3D printing method, but before us, you couldn't really get access to this technology without paying like $60,000 to $100,000 for a printer. So when we brought out the Form 1 for $3,300, this was very exciting for people who do a lot of 3D printing. So people like stereolithography because the parts are extremely smooth straight out the machine, and you can do a lot of complex detail and create some beautiful prints. So all the parts here are actually in our standard resins, which are available in clear, white, gray, and black. But our new material, which I'm going to focus on, was designed to be incredibly tough. And these slides are not in the order I was anticipating. OK, so our tough resin, which I have here, and it's actually on display for the first time at our booth, so I encourage you to come by and play with it, was designed to solve the problem which is common with stereolithography resins, where they may be beautiful, but they can be a little bit brittle. So our tough resin was designed to be impact resistant. So if you drop it, it's not going to smash. It's got a little bit more give to it. And to celebrate this launch, we made a Rube Goldberg machine, which shows some of the properties about tough, which are pretty exciting. So I'm going to play that now. Is there silence? I can put it back. There is no sound, but it's very dramatic. So all these parts are actually printed in our tough resin. So it's very machinable. All right. So that's our tough resin. So like I said, yeah, the sort of problem is trying to solve for engineers and designers is that these resins can be a little bit brittle. However, so tough is designed for any prototypes that are functional. You're expecting them to go through actual force or wear. So this would be perfect if you wanted to print like snap fits or living hinges. So nowadays, a lot of plastic products have these sort of features that bend and click, and it's all built into the injection mold. And this is a perfect resin for prototyping that. So to put this in context, these are our sort of range of standard resins. We have clear, white, gray, and black, and they're all photopolymers. And when I talk about toughness, it's actually talking about the area under a stress strain curve. So here we compare it to our standard resins. And with tough, we've really developed it to have a balance of good strength and good elongation. So while our standard resins are actually slightly stronger, they have poor elongation. So if you apply a high force and it goes beyond that point, it's just going to fracture. Whereas with our tough resin, if you keep applying or increasing the force, it's more likely to give, and it will sort of bend rather than just fracture. And that can be a desirable property if you're trying to make something that like you're wearing and it's getting knocked about in like day-to-day use, and things like gears. And in general, there is sort of this idea that stereolithography resins can be brittle, but I want to emphasize that the materials are really developing alongside the technology. And if you're printing chunkier things, they can withstand pretty high loads. So yeah, really excited to see what people do with this resin in terms of moving towards functional designs or end-use prints. And also with Formlabs, I kind of started this by explaining that we were one of the first people to bring stereolithography, and while in the desktop space we might see one of the pricier printers at $3,300, from the sort of industrial space, we're really making this technology affordable. And here we're kind of comparing our new Formlabs Tough to some of the resins available from high-end industrial-grade 3D printer manufacturers. And you can see that the properties are, in some cases, better, if not totally comparable to some of the best-in-class materials out there that cost 3 to 4 times what our Formlabs Tough costs. So we continue to bring high-quality 3D printing and make it more affordable, accessible, but also bring high-quality materials to the desktop space. And we're pretty confident that this is actually the toughest material available for desktop printing. And Tough is the third in our line of functional resins. So that's really been a focus for us this year. So in October, we kicked off functional resins with 2 materials, which we also have on display at the booth. We actually have a flexible resin and we have a castable resin, primarily used by jewelers. And the flexible is really fun for sort of making complex prototypes that have different tactile properties, and it's being used a lot in the biomedical device industry. So yeah, this is the Formlabs ecosystem. Another thing I think is quite unique is we do everything at Formlabs, so hardware design, software design, materials development, and when you buy the printer, it comes with resin and a finish kit and everything you need to get started. And beyond materials development, which I focused on, we're also sort of expanding the ecosystem with new service offerings. We have distribution in Japan. We do support in different languages now. And we have a fantastic customer support experience. So we're consistently rated as one of the best 3D printers on 3D Hubs. And yeah, it's a fantastic SLA machine. So really encourage you all to come by the booth to see more. And if you have any questions, feel free to talk to me or email me. And have a great CE week.